It may also be interesting to inspect the cancer membrane to investigate cancer structure. I've already scaled the CanSem matrix to something reasonable to view. Notice how trying to display the original image will give an error because we've reached the maximum image size. Here it is. Notice the large and small blobs. It may be interesting to count the number of blobs and get an idea of their locations and size. The label function would do just that. We need to define a minimum size. I'll assume for the moment that a typical cancer cell has a radius of 10 microns. Therefore, the size would be about 310 microns squared. Now let's let this run. Notice that the analysis page is fully parallelized. There is no limit to the number of commands that can be executed simultaneously, and all available CPU cores will be used. Compare this to other languages such as R and MATLAB, which take single commands in series and only use one processor. The labeling is now done. We have about 300 blobs of 310 microns squared or greater. Here are the sizes and centers of them. Now, it may be interesting to investigate how close one cell population is to another. Let's see how many immune cells are within 50 microns of a metastasis. We'll use the num within radius function. How about the number between 50 and 100 microns away? We'll use the num within ring function. Here are the results. There were a lot of immune cells close to cancer, and there's also a lot of immune cells that are within a fair distance from cancer. The general question may be to ask, what is the distribution in general? That is, somehow illustrate the distance from every T cell to the closest cancer nucleus and display the results as a histogram. We'll use the distance away distribution function. This illustrates that most are within 100 microns from cancer. Now, if the same analysis is to be done across many scans, it doesn't make sense to type the same commands many times. Luckily, there's a scripting function. I created a script with analyses I'd like to see performed. The script can be executed by using the script menu and selecting the file. At the end of the script, it displays all tasks joined. If you need one task to execute strictly before another, the join command will force all previously executing tasks to complete before accepting new ones. Now, at the end of the analysis, it may be convenient to have output that you can email or show at a presentation. The report feature will do just that. The auto-generated PDF includes a thumbnail, as well as a transcript of the analyses and their results. I hope you got a glimpse of the power of GemIdent technology in these 3 demos. The development is still in its infancy. Support for more automated microscopy systems and new analysis functions will be added in the near future.